Hi, in this video I'm going to show you how to subtract fractions and mixed numbers. We're going to start with just how to subtract fractions. From other videos you should already know that to subtract fractions we need common denominators. And there's a trick for finding common denominators, but sometimes that trick, if I use this denominator to multiply with this fraction, and use this denominator to multiply with this fraction, sometimes that trick doesn't give us a great common denominator. It'll always give us a common denominator, but sometimes it's not the least common denominator. So this would have given us 24 over 36. We could certainly work the problem from here, but it would be also better to notice that in this case, because the first fraction is out of 12 and the second fraction has a denominator of 3, that we only need to convert the second fraction because we can get this to have the same denominator as the first one. Well, how can I turn 3 into 12? I can multiply it by 4. So if I convert just this fraction, well, the first fraction would still be 11 twelfths. And the second fraction, 2 times 4 is 8, and 3 times 4 is 12, is just 8 twelfths. Okay, well, subtracting is similar to adding. And when we add, we just add the numerators. So when we subtract, we just subtract numerators. 11 minus 8 is 3. And we keep the denominator the same, 3 twelfths. Okay, so 3 twelfths is the answer to this problem. Let's start working on subtracting mixed numbers. Okay, let's try 2 and 2/3 minus 1 and 1/4. So just like when we're adding, we need to make sure we have fractions with common denominators. And to get the common denominators here, I'm going to use the trick to just multiply by the other denominator for each fraction. Well, 2 and 2/3, if I convert the fraction by multiplying by 4/4, I end up with 2 and 8 twelfths minus 1 and 3 twelfths. Okay, well, that seems like I have common denominators now, so I'm ready to subtract. And when I subtract, I'm going to do my subtraction vertically also. It's important when I do the subtraction that I set it up properly. I take the first number and I write it up top, 2 and 8 twelfths. And I'm going to subtract from that 1 and 3 twelfths. Okay, well, with subtraction, just like addition, we usually work from the smaller place values to the larger ones. And I'm going to start by taking 3 twelfths from 8 twelfths. So I'm thinking 8 minus 3 is 5 twelfths, and 2 minus 1 is 1. So my answer is 1 and 5 twelfths. Let's try another one. Okay, the next example, we're going to subtract 2 and 3/5 and 1 and 3/4. So again, we'll convert the fractions to have a common denominator by just multiplying by the denominator from the other fraction. So now our fractions are 2 and 12/20, and I'm taking away 1 and 15/20. So I'm going to put them vertically. Remember, the first number comes on top, and I'm going to subtract the second number. Well, when I try to take 15/20 away from 12/20, if you're thinking 3/20, then you did the subtraction in reverse. You took 12 away from 15 instead of trying to take 15 away from 12. If you have $12 and I need $15, I'll take all your money, but I'll still need $3 more. I wouldn't actually do that. That's cruel. But anyway, in order to do this subtraction, when the number above, let's think of another example. Let's say I had 22 and I wanted to take away 13. Well, when I go up to try and take 3 away from 2, I can't do it. So the usual way that we handle that in subtraction is we borrow from the next number over. Well, in this case, I'm going to borrow from the tens place. I'm going to take 10 of the, turn this 2 into a 1. And when I borrow, I get to put 10 here. So this becomes 12. Let's think about why that is for a second. How come I get to add 10 to this place? The reason is that one of these, so if I turn a 2 into a 1, if I take one of these, it's equal to 10 of these. That's because our place value. In tens, each 10 is worth 10 ones. just by the place value. And that's true for all the place values in our decimal system. If you think about numbers, if I take one of these, that's worth 10 of these. So with integers or whole numbers, all the place values have this property that 1 of the number to the left is equal to 10 of wherever you currently are. If I try to borrow from this 2 and I take one of these whole numbers is not going to be worth 10 of these. One whole is equal to how many 20ths? Well, one whole is equal to 20 20ths. So in this case, when I borrow, I have to take one whole and turn it into the same quantity, but in 20ths. So one whole is 20 20ths. I get to add that in here. That makes this 12 plus 20, 32 20ths. So this borrowing is a little bit different when we start to borrow with mixed numbers, but it's based on the same principle that if I don't have enough to take away, I'm going to borrow from the whole number. But I don't get 10, I get whatever the denominator is, right? Because that's how many pieces that are in a whole number. So I take 1 from here and I turn it into 20 20ths and add that in to the numerator here. All right, hopefully you followed that. Now we're ready to do the subtraction. If I want to subtract 15 20ths from 32 20ths, I'm now ready to do that. There's enough 20ths here for me to do the subtraction. 32 minus 15 is, well, let's see, 32 minus 15, okay, I guess I'd have to borrow anyway. 12 minus 5 is 7, and 2 minus 1 is 1. So 32 minus 15 is 17 20ths. And 1 minus 1 is 0. So 0 and 17 20ths. And we should probably just write that as 17 20ths. That'd be the answer. Okay, let's try one more problem. In this one I'm going to do 15 and 5/6 minus 12 and 9/10. And I'm going to start by multiplying, using my trick to find a common denominator. So I'm going to use this denominator to multiply this fraction by. And I'll use this denominator to multiply the other fraction. So let's see, I'll end up with 15 and 50 60ths minus 12 and 9 times 6 is 54 60ths. All right, well, I have common denominators, so I'm going to line up my fractions. Remember, the first one always goes on top, 15 and 50 60ths minus 12 and 54 60ths. When I start to subtract, I see that I don't have enough 60ths, so I'm going to have to borrow. So I'll take 1 from here, and I get 1 of these is equal to how many of these? Well, 60 60ths would be one whole. So I get to add in 60 60ths here, and 60 plus 50 is 110. Okay, so I'm ready to subtract. I can take 54 away from 110, and I'll do that over here just to make sure I get the right answer. It's going to be a lot of borrowing here. 10 minus 4 is 6. I have to borrow again to do the next subtraction. 10 minus 5 is 5. Okay, and 110 take away 54 is 56, and I think that makes sense because 50 plus 50 would be 100, and 4 and 6 would make the 10 more that I need. So 110 minus 54 is 56 60ths. And now I had 14 after I borrowed, so 14 minus 12 is 2. And I noticed that I didn't, I get my answer, but it doesn't look like it's in simplest form because I have 2 even numbers here. So I know I could simplify this fraction a little bit more. So I'm going to show 56 over 60, and I just want to think about how I could simplify it. Is there any number that I can divide from the numerator and the denominator? Well, I know I could divide them both by 2. If I divide 56 by 2, I get 28. And if I divide 60 by 2, I get 30. So this fraction would be equal to 28 30ths, which again is even on top and bottom. So I could divide these by 2. And that would give me 14 over 15. So I think the simplest form of this fraction is 14/15. So the answer should be 2 and 14/15. And I think that that should finish up our explanation of how you subtract mixed numbers. Let me just kind of give you the main ideas. When we subtract, we need common denominators. So you saw that I always converted to make sure that I had the denominators match. You can use a trick for that, which is to just use the opposite denominator, so the denominator of the other fraction. Or you can think about a number that both of these go into. In this case, 6 and 10 both go into 30. 6 times 5 is 30, and 10 times 3 is 30. So I could have used 30ths here. But even still, even if you use the least common denominator, it's called, so I'll put least over here. This sometimes shortens the process. Sometimes you still have to simplify the fraction at the end of the problem. We talked about borrowing, and borrowing is a useful skill to bring into fractions. It can make these problems much easier, but it is important that you always think of borrowing as converting one of something into another place value. I'm converting a 1 from the ones place into these fractions. In this case, there were 60ths, so I needed 60 60ths from one whole. So borrowing is kind of, we learn a new way to borrow when we work with fractions and mixed numbers. And finally, you have to make sure that you always reduce your answer by trying to divide the fraction, the numerator and the denominator, by the same number until you can't find any other ways to divide it. Okay, I think that is it. Good luck.